Hello viewers, now I am going to draw shear force and bending moment for this given overhanging beam. This is one of the overhanging beam, and so it is carrying one of the 3-point loads. 800 newtons is one of the point load, and 2000 newton it is one of the point load, and 1000 newton is also one of the point load acting. This 800 newtons acting at this end, and 1000 newton it is acting at this end, and this 2000 newton acting at the distance of 5 meter from support A. Assume it as a support A, and this is B, and C, D, and E. Okay, so now I am going to draw shear force and bending moment diagram for this given overhanging beam. Okay, so first let me determine the shear force and bending moment at different cross sections, and then after I will draw the shear force and bending moment diagrams. So for equilibrium of this overhanging beam, already we know for the equilibrium algebraic sum of all summation of all vertical forces should be equal to 0, and so let one of the reaction will be there at A and another reaction will be there at B. These two are acting at the upward. So here let RA and RB two reactions at A and B respectively, and now so for equilibrium summation of vertical forces, that is summation of V, should be equal to 0, and the summation of moments also should be equal to 0 at some particular cross section, right? So then what it will be according to this, so then RA plus RB and minus 800 minus 2000 minus 1000, it is equal to 0. Means these RA and RB acting upward, and these 3 point loads acting downward. So that summation, this RA plus RB equal to, I can write this is 2000, 3000, right? 3000 plus this 800, total it will be 3800 newtons is the RA plus RB should be equal to 3800 newtons. And next, if I take moments, by taking moments due to forces at A, so I am taking moments due to forces at A. So then what are the moments at about A? Forces, by taking moments due to forces about A, right? Okay, about A. So what are the moments will be there? So one of the due to RB reaction, one of the moment will be there, and this point load and this point load and this point load, due to these 1, 2, 3, 4, due to these four forces and moments will be there. If I write sum of moments, then it will be RB into distance. RB into distance, I am writing all the moments about A. RB into distance, so what it is? It is 8 meters, and this is the anti-clockwise moment, and the remaining moments, this is also one of the anti-clockwise moment. I will write here anti-clockwise moment, because due to this load, this moment will be in this direction, right? So this is also means that is about A. If I write the moment due to this 800 newton, 800 into 3 meters, it should be equal to these two moments are in clockwise direction, but about A, if you see the moments due to this one, this 1000 newton and this 2000 newton, the moment will be in anti-clockwise direction, right? So these are the clockwise moments, and I am writing anti-clockwise moments on the right hand side. So that is 2000 into distance up to A, that is 5 meter plus here also it will be place, okay? And next 1000 into 10, 8 plus 2, isn't it? Okay, so due to this point load moment at A, we can write this force into 2 meter and 8 meter. 2 plus 8, 8 plus 2, 10 meters. Okay, it is 2000 into 5 plus 1000 into 10. Then what it will be? If we do the simplification, it is 10,000, right? 10,000 plus this is also 10,000, and it will be total, it will be 20,000 Newton, right hand side. And in the left hand side, if you see, RB into 8 plus 8 into 800 into 3, that is 2400 equal to 20,000 on the right hand side, right? And RB into 8 we can write, it is 20,000 minus 24800. So then RB equal to 20,000 minus 20,000 minus, sorry, it is 2400, right? 20,000 minus 2,400, and it will be 17,600. It is 20,000 minus 1,800, it is okay, into 8. So it will be RB equal to 17600 divided by 8. So this is the reaction at B. So what will be the reaction at B? So this is 8 2s, 1 will be remain, and 8 2s, 2200, 2200 newtons. So RB equal to 2200 we got. Then what we get? Then by substituting this value in equation 1, then RA will be obtained. But we know that RA plus RB equal to, what is that one? 3800, and then RA equal to 3800 minus RB. So it is equal to 3800 minus 2200. It is equal to, this is 800 plus 1600 is the RA. Okay, so 1600 is the RA. You will get 1600. These are the two reactions acting at A and B. So this is what RA equal to 1600 and RB equal to newtons. It is RB equal to 2200 newtons. Okay, so in this way we determine the reactions. After determination of these reactions, now we determine the shear force at different cross sections. Okay, so then shear force at C. Shear force at C, if we see, what will be the shear force? 1000 Newton is there, and that is acting downward. So F suffix C equal to, so it will be 1000 Newton, and it is acting downward, right? So it will be positive, and this one will be the shear force. So now what is the shear force at B? Shear force at just right of B. So because this RB is one of the reaction acting upward, and this is also one of the point load acting upward, right? So right of the section and left of the section shear force will be different. So that is the reason I am writing here shear force at just right of B equal to F suffix B equal to, so only 1000 newtons only. Why? Because from, if you take cross section, here also shear force is 1000 Newton, and here also it will be 1000 newtons only. So shear force at just right of B, it will be 1000 newtons. Next shear force at just left of B. So if we take left of B, just left of the B, if we write, then it will be this RB also included. For example, if I take cross section here, then if I take right of that section, if I take, okay, so this force and this force, these two forces are there, right? So I had written here that what is that shear force at just left of B means this RB also included right of the cross section. Then what is the shear force at just left of B, that is F suffix B equal to, and it is RB, that is 2200. It is acting upward, right? It should be minus, and the downward force is what? It is 1000 Newton, and it is 2200 minus 2200 plus 1000. It is minus 1200. Minus 1200 is the shear force at just left of the B. But if we see the shear force just right of the B, what is the shear force we got? It is 1000 newtons, and it will be constant from B to D. Okay, so now shear force at just right of the D, right of D, so that is F suffix D equal to, so shear force just right of D also it will be minus 1200 only, and shear force at just left of D, so left of D, that is also F suffix D equal to, if we take just left of the D, if I take cross section just left of D, and if I take the right of the cross section, then this 2000 Newton is also included, right? So that is the reason sudden change in shear force takes place where the point load acts, right? And it is this 2000 is one of the force acting downward. We have to take it as a positive by applying sign convention. And next one is upward, 2200, that is RB acting upward, that we have to take negative. And one more force is there, right? That is 1000 Newton acting downward, we have to take it as a positive. 2000 and 1000, 3000 minus 2200, it is 800 plus 800 newtons is the shear force just left of the D, and this shear force 800 newtons, it will be constant from D to A. Why? Because it is not dependent on the length, right? It is okay, so this one will be constant up to A, and the shear force at just right of A, you will get F suffix A equal to 800 newtons only. But if I take just left of the A, so then what we get shear force at just left of A. So what will be the shear force just left of A? So left of A, if we take cross section, then if I take the right of the portion, then what it will be? This RA also included. Okay, RA, right, what are the all forces acting right of this cross section? RA 2000 and RB, and this is one of the 1000 newtons, right? And otherwise you can take left of the section also. Okay, so if you take left of the section also, you will get same, right? And shear force is just left of A, and if I take the left of the cross section, then here 800 newtons is acting and it is downward. Okay, if we take cross section here, if we take right of that if we take the left of the cross section, okay, the force is acting 800 downward, right? If we take cross section somewhere, and if we take left of the cross section, so that sign convention we have to apply, right? So if the forces acts downward, then we have to take it as a positive, and if the forces acts upward, if the forces acts, if we take left of the cross section, if the forces act downward, we have to take it as negative, and if the forces act upward, those we have to take as a positive. It is opposite to this if we take right of the cross section, right? So then shear force at just left of A, it will be equal to F suffix A equal to minus 800. Why? Because it is acting downward. If I take the left of the cross section and the downward forces, I have to take it as a negative. Otherwise, if you can take right of the cross section, but some calculation will be more. Okay, so I will take here just right of cross section. If I take right of cross section, I am writing here A, RA, ORR, FA equal to 800 newtons. Okay, this is just left of A, but I am determining the shear force just left of A by taking right of the cross section. So here also you will get same minus 800. Okay, let me check whether you are getting or not. Okay, so this is the, if I take the right of this cross section, upward force how much is acting? 1600, we have to take it as a minus 1600, and here RB equal to 2200, that is also acting upward, we have to take it as a negative. And next one is these two forces acting downward, we have to take it as a plus. Okay, and 2000 plus 1000. So what is the summation of all this? This is 2200 and 1600, 2000 at 3000, it will be 2000 at 3800, it will be plus, and here it is 3000, right? 2000 plus 1000, it is minus, right? Okay, so it will be minus 800 newtons. Okay, if I take right of the cross section also, I got the same value, that is minus 800, right? So you can take right of the cross section or left of the cross section, but you have to apply the sign convention carefully. And these are the shear forces at different cross sections, right? And these all the forces are acting are point loads, and variation of the shear force between any two points, like from C to B and B to D and D to A and A to E, shear force will be constant. Okay, horizontal line, there will be no slope. Okay, so these are the shear forces at different cross sections we determine, and then after we determine the bending moment at different cross sections, and then we draw the shear force and bending moment diagrams. Okay, so this is about the shear force. So next we determine bending moment. Okay, and let me, okay, I'll have to take this screenshot or pause the video and take the notes of it, then I will rough it, and then I will determine the bending moment at different cross sections. Okay. Okay, if you see here the shear force variation after D or some B. So here what is the shear force at B? We are getting minus just left of B, we are getting minus 1200, and shear force just right of B, it is also minus shear force at just left of B. Left of B is how much we got? Minus 1200. Shear force at just right of D, this is D, right? This is D, right of D also 1200. Shear force at just left of D, you are getting 800 newtons. This is positive, right? Here sign, this is at the point D. Okay, so shear force changes its a sign, means what? Bending moment will be maximum at point D. Okay, that is at a distance of 3 meter from B. That if the distance between A and B is 8 meters and the distance from A to D is 5 meters, remaining distance will be 3 meters, right? Okay, so bending moment will be maximum at this D, we will determine, right? Okay, so next bending moment at C. What is the bending moment at C? So bending moment at C we get 0. Why? Because bending moment at C, okay, so what is the force is acting? 1000 Newton is acting, and that is there is no distance between the cross section, right? Okay, so shear force bending moment is 0 at C. Bending moment that is m suffix c equal to 0. And next, what is the bending moment at B? Bending moment at B, m suffix B equal to, so due to this force, if I take cross section at B and right of the cross section if I take, due to this load bending moment will be there, that is equal to 1000 force into distance. What is the distance from B to C? It is 2 meters, right? And what is the sign convention we have to apply? It is hugging moment. Okay, this beam may bend downward, right, like this. Okay, so it is a hugging moment. Okay, that is the reason we have to take it as a negative, and it is 2000 Newton meter. This is the bending moment at B. Next one is bending moment at next point is D. So m suffix D equal to, if I take cross section at D I have to take the cross section at D. So if I take the right of the cross section, what are the forces we are having? RB is there and another one point load is there, right? Due to these two loads, bending moment will be there at D. So what is the bending moment at D? It will be equal to 1000 into distance, this force into distance up to D. So what is up from here to here? It is 2 meters and remaining distance will be 3 meters. Why? Because the distance between A and B is 8 meters and up to D it is 5 meters. Remaining distance will be 3 meters. This is 3 meters, right? Okay, so this is 1000 into 3 plus 2. This, what is the sign convention for this? It is minus, because due to that one beam may bend in clockwise direction. And next one is due to RB, we write that is the sagging moment, right? Due to this force, sagging moment will be there, and it is positive into positive. What is the load we are having? 2200. And what is the distance we are having from B to D? That is 3 meters. 3 meters, right? It is what is 5 into 1000? It is minus 5000 Newton meter, plus it is 2200 into 3 and 6600. Next one, so if we do the simplification, 5000 plus 1600 Newton meter. This is the bending moment at D. And next one is bending moment at A. Bending moment at A, if we write, so for determination of bending moment at A, you can take right of the cross section or left of the cross section also. If I take the left of the cross section, okay, so but the proper sign convention you apply, but I will take always right of the cross section. I don't want to make you more confusion. And bending moment at A, that is M suffix A equal to here now we are having three forces. These two are downward forces and this is the upward force, right? Moments due to those forces, if we write 1000 into what is the distance, this 8 meters plus 2 meters, it is 10 meters. What is the sagging moment? That is the downward force, right? We have to take it as a negative. And next one is RB into distance. RB is how much? 2200 into 8 distance. 8 is the distance. Next moment due to this downward force, it is acting downward, we have to take it as a positive. 2000 into distance is 5 meters. And if we simplify, this is 10,000 minus 10,000 it is, and this is 22 into 8. Okay, so 6 1 16 17 17,600 plus this is 10,000. Okay, and this 10,000 and this 10,000 get cancel, and it is minus 17,600 Newton meter is the bending moment at A. And next, what is the bending moment? Bending moment at E. What is the bending moment at E? Bending moment at E, it will be equal to 0, because if we take here, if we take cross section at E, so due to this force at the left of rotation, there is no load and there is no distance. That is the reason you will get a bending moment at E, you will get 0. Or if you take right of the cross section also, and if you do all the calculations here also, bending moment you will get 0. And next one is, see this bending moment variation between any two parts like C to B and B to D and D to A and A to E. Bending moment variation will be linear. Okay, so because only distance is only x power 1 is there, right? Okay, so because these are all the point loads, for the point loads bending moment will be linear. Okay, linear variation will be there, and these are all varies this bending moment varies between any two points linearly, right? And these are the bending moment values. According to these, we will draw the shear force and bending moment diagram. Okay, to draw the shear force and bending moment diagrams, okay, I have taken two baselines. Okay, this is for the shear force and bending moment. What is the shear force at C we got? It is positive 1000 newtons, right? And this is the magnitude of 1000 newton, and it will be constant up to point B, and this is the 1000 newton. And what is the shear force just left of the B? It is minus 1200 newtons. Okay, minus 1200 is the newton, and it will be constant up to point D. And what is the shear force just left of D? It is positive 800. So this is 800 newtons. And next, what is the shear force just left of A? It is minus 800. This is 800 newtons. Okay, so this one will give the shear force diagram. This is positive, positive, negative, negative. And next one is bending moment. What is the bending moment at C? It is 0. And what is the bending moment at B? Minus 2000. It is minus to the linear minus 2000. This is 2000 newton, this magnitude, right? And next one is bending moment at D. It is 1600, positive 1600, positive 1600. This is 1600 newtons, Newton meter, and this is Newton meter, right? And next one is bending moment at A. Bending moment at A, what we got? Bending moment at A minus 17,600. Then minus 17,600. Minus 17,600 Newton meter. And what is the bending moment at E? It is 0. Okay, this is the bending moment diagram for this given B. Okay, so this is negative, positive. Okay, like this you have to draw the bending moment diagrams. Thank you.